In section 2.5, we learn about something called the normal distribution, which really serves as the backbone for the entire rest of the course. So in the last section, we applied the empirical rule to this bell-shaped histogram showing the ITBS vocab scores for students in Gary, Indiana. We know the mean and the standard deviation, which are shown here. And we're curious as to how unusual is it for a 7th grader to get a vocab score less than 4. Now, if we write it out with the empirical rule, we take the mean, we put it right in the center. These three numbers on the right come from adding the standard deviation, 1.55, to the mean again and again and again 3 times. On the left, it's the same thing, but we're subtracting 1.55 from the mean 3 times. And the difference of this problem compared to what we did in the last section is 4 isn't exactly on one of these numbers. So it's in between the 3.74 and the 5.9. So we can't use that 68, 95, 99.7 rule. And instead, we're going to use what we learned in the first section of this chapter, which is the z-score. As a reminder, a z-score tells us how far a data point is from the mean measured in standard deviations. So we're going to take our data point, that 4, we subtract the mean of 6.84, and then that difference gets divided by the standard deviation of 1.55. So here we can see it with all those numbers filled in, and if we do the calculation, we get a z-score of negative 1.83. Now, the z-score is showing us a standardized value. In a standardized distribution, we have a 0 right in the mean, because anything with a z-score of 0 would be equal to the mean. And for any problem like this, we want to sketch out the curve. So we have negative 1.83 as our z-score, right, which is, we'll call it right about there. And we're interested in finding the probability that a student gets less than a 4 or less than the z-score. All right, so we would shade it to the left there. Okay, so here we can see our original sketch of the curve. This is the same sketch except it's using z-scores instead of their vocab scores. So the next step in solving this problem is to figure out what's the actual area of this green shaded section of the curve. Okay, and it would be the same in either of these. So to figure that out, we're going to go to our standard normal probabilities table. I've probably given it to you as a yellow table that has a whole bunch of numbers on each side. All right, so take that out and take a look at it. You'll see something that looks like this. One side is going to have a bunch of positive numbers. The other side is going to have a bunch of negative numbers. We want to be on the negative side for this one because we're looking for a z-score of negative 1.83. That was our z-score. All right, so to find this in the table, first we're going to take the whole number in the decimal. We're going to cut off that 3 at the end, negative 1.8. And we're going to look for that on the side here. Okay, we see it right there. All right, so we're on this row. All right, and the next thing we're going to do is look at that number right at the end, okay, which would really be a 0.03. And we're looking for that up top, all right, which means we're in this column. And we're just going to go down and find where they intersect. And they intersect right there. You can see that's a 0.0336. All right, here's a cleaner version of what we're looking for. All right, and that's telling us what the actual probability of a student scoring below that 4 on the test is. Okay, every number in this table is always telling us the area to the left of some z-score value. All right, let's do another example here. So here we have the distribution for stopping distance of cars traveling at 60 miles per hour. Tells us that they have a mean of 165 feet, standard deviation of 4 feet, and that the distribution is approximately normal. Question is, what percent of cars would be able to make an emergency stop in less than 170 feet? So the first step for any problem like this is to actually sketch out what we're looking for. We draw this little bell curve. We're going to put the mean right in the middle. Okay, we don't need these numbers here. You can skip all those. All right, what we do want is the cutoff for what we're looking for. So we want to make this emergency stop in less than 170 feet. So we're going to draw that line on the curve. And we're going to shade to the left because we're looking for the probability that we can stop in less than that amount of time. Now from there, we want to calculate a z-score for that value. So we take that 170, we subtract the mean of 165, divide by 4, and we have our z-score of 1.25. Now we look at our table. Okay, and remember, when we look at our table, we're looking for the stem first, 1.2. That tells us the row that we're in. And then that 5 is really 0.05. That's what we look for across the top. That's the column we're in. And we look for where they intersect. So see if you can find that on your yellow standard normal probabilities table. That's giving us our percentage. That's the area that shaded section occupies, and it's our answer for the question. So about 89.4% of cars would be able to stop within 770 feet. Now, both of the examples so far have been finding areas to the left of a given z-score. Okay, we've been shading to this side of the curve in both of them, but that's not always the case. Sometimes we want to go this way. All right, and find the probability of getting greater than 4, or the probability of cars that won't be able to stop at 170 feet. Okay, the table is always giving area to the left. So when we're dealing with something like this and it's shaded to the right, we have an extra step. And basically, the key thing is to remember that this entire curve totals 100%, or 1. So if we want to find the area of this red shaded section here, we're just going to subtract the value from 1. So back to that first example we had done, the probability of getting a score of 4 or less was 0.0336. So the probability of getting a score greater than that would be 1 minus 0.0336, or about 96.64%. So let's try an example like that. So here we have the distribution of golf drives hit by a professional golfer. We can see that the mean is 304, standard deviation is 8. What percent of this golfer's drives travel at least 290 yards? Is he likely to hit the ball that far? So again, first step with these always is to sketch out this curve. We have the mean of 304 right in the center. Right, 290 is down here. Okay, again, you don't need to write all of these 1 standard deviation, 2 standard deviations, 3 standard deviations from the mean. I'm just going to be looking for the mean and that cutoff. Okay, we're shading to the right this time because we're finding the probability that he hits this ball at least 290 yards. After we have that curve, we want the z-score, 290 minus 304 divided by the standard deviation of 8. We're going to get a negative z-score this time, which makes sense because this value is below the average. Anything that's below average is going to have a negative z-score. And we look it up in the table. So negative 1.7 is the stem. Make sure you're on the negative side. 0.05 is the leaf there, which is the number at the end. And they intersect at that 0.0401. Okay, but remember, this is always telling us the area to the left of that z-score. So that's actually telling us right here. Okay, and that's not what we want. We want the other side of it. So to get the other side, we're going to do 1 minus this value. This is 0.0401. Everything this way is 1 minus 0.0401. So together, they total 100%. I don't know why my marker does that sometimes, but so about 95.99% of his drives travel at least 290 yards. It asked, is he likely to hit it that far? Yes. Okay, he does so the vast majority of the time. One more type of problem. Suppose we want to estimate the proportion of Gary, Indiana 7th graders with ITBS vocab scores between 6 and 9. Right, so in this case, we have really 2 boundaries. It's not going all the way to the left. It's not going all the way to the right. Instead, it's in between these 2 values. So what we want to do in this case is find z-scores for both of them. We get a z-score for 6, and we get a z-score for 9. Now, once we have those z-scores, the calculation is fairly straightforward. We're trying to find the proportion of students that score between a 6 and a 9. All right, we found those 2 z-scores, which really means we're looking for the area that's in between a z-score of negative 0.54 and 1.39. So the way we're going to get this section, okay, it's not going all the way to the end over here. It's not going all the way to the right. All right, it's just in between those 2. So to start off, let's look at the higher one, the 1.39, okay, which is here. We can look that up in the table, right? And when we do, we should see it's 0.9177, and that's going from all the way to the left. Okay, but we don't actually want to go all the way to the left. We want to stop at negative 0.54. And to do that, we're really just taking all this extra on the left here, and we're taking it out. We're taking it away. So if we look up that negative 0.54, okay, we can figure out what the area is that way, the amount that we want to take out over here, which is 0.2946. And we're just going to subtract those two values. So the area in between the two, in this shaded section, same as this over here, is going to be those two probabilities subtracted. 62.31% of students earn between a 6 and a 9.